Hi friends, welcome back in this series of recommendation system. So today we have another type of recommendation, that is collaborating filter recommendation. So basically we will be making one popularity based model and one collaborative filtering model, right? To see like how they are different and how we can apply them. But before starting again, as I discussed regarding popularity based, that means which is in trend. Anything is trend, that means popular. For example, popular news, popular mobiles. And we have seen some examples or some use cases on the popularity based recommendation. Now we have another term, that is collaborating filtering. So collaborating filtering, what it will do is, so basically if I say, if a person X likes in items ABC and Y likes items BCD, then they have a similar interest, and X should like item D and Y should like item A, right? So here assumption is customer who had a similar taste in the past, so they will have similar taste in the future. For example, popular Amazon, right? So this is how their product recommendation works. But yeah, let's start with the case study and we will get to know that how we can apply it. So here we have the example on foods rating. So basically it is asking generate a top and list of restaurant on customer preferences. So that is basically on restaurant and customer data, right? Now the data set was obtained from recommender system prototype. The task was to generate a top and list of restaurants according to consumer preference, and the collaborating filtering technique used only in rating final CSV. So I'll be providing the CSV in the description as well, or you can get it from this link, right? So let's start one by one. We are importing library. Actually our team has done this on Google Colab. So of course we are mounting the Google Colab, and rest thing are same, like importing necessary library. So here you can see we are importing interactive shell, right? And we are having the node interactivity, that is all. Now the important libraries like NumPy, Pandas, Math, JSON, Time, right? Matplotlib, Seaborn, and sklearn matrices like cosine similarity, train test split for our model building, nearest neighbors, joblib, right? scipy.sparse, CSR matrix for sparse from sparse, right? And yeah, ignoring the warnings. So the first step is to read and explore the data set. So here the data set final rating, or the rating final, I'll be providing the link of the data set in the description. So if we get the head of it, so here you can see that these are the top 5 values of this rating final data set. So we have user ID, place ID, rating, food rating, and service rating. Now check the number of rows and columns. So we have number of rows as 1161 and number of columns as 5. So this is how you can get rows column equals to df.shape, because df.shape always written row and columns. Now checking the data type. So this is the data type of all our 5 columns. User ID is of object, rest are integer. Now check for the missing values percent. So we are using df.isnull.sum. So if there are any missing values, no, there are no missing values. Now to get the 5-point summary, so here we will get is df of rating. We are getting only of rating dot describe dot transpose. So for rating you can see that count, mean, standard deviation, minimum, the interquartile ranges, 25th percentile, 50th percentile, 75th percentile, and the maximum values, right? Now find a minimum and maximum rating. So here if we get the minimum, so of course rating dot min function and rating dot max function will return the values respectively. So minimum rating is 0 and maximum rating we have is 2. So we can assume that rating are on a scale from 0 to 2, right? Now check the distribution of rating. So with sns.access style white, right? So these are nothing but the access style. G equals to sns dot factor plot we are having of rating. Data we are passing df, and aspect we have 2.0. Count is the kind. Now you can see the y label we have as total number of rating, and x label of course the rating. So here for 0 we have rating between 200 to 300 ratings. For 1 we have around 400 number of ratings, and for 2 we have between 400 and 500, right? Now number of unique user id and product id in the data. So we print the n unique of user id and n unique for place id. So number of unique users in raw data, so it is 138, and number of unique items in raw data, it is 130. Now take subset of data set to make it less sparse, more dense. For example, keep the users only who has given 50 or more number of ratings. So top 10 users based on rating. So most rated equals to df dot group by user id dot size. Short values are ascending equals to false. That means it will be in descending order, right? And up from 0 to 10, and most rated. So here you can see that we are getting all these user id. Now calculate the density of the rating matrix. So final rating matrix df final dot pivot. Index equals to user id, column is place id, and value is rating. Similarly, if we print the shape of final matrix, so here you can see that the shape of the final matrix we get it from here, right? Similarly, given a number of rating, so given number of rating we are getting from here. So in our case it is 1341 or the 1341, and possible number of ratings, so we have 1420. Now the density we have is 94.44, right? Now final rating matrix dot head. So if we get the head, so you can see that we will get the rating of all these food items respectively. Now matrix with one row per product and one column per user for item based collaborating filtering. So final rating matrix transpose dot head. So here you can see that we are getting one row per product and one column per product, right? Now split the data randomly into test and train. So we are having 30% for test size, and of course remaining 70% is for training. Now we do the train test split, and then we get the train data dot head. So this is our train data, this is the shape of train data, and this is the shape of test data. Now first, again as I said, first we are building a popularity recommender model, right, which is non-personalized in this case. So count of user id for each unique product as recommendation score. So train data grouped equals to train data dot group by place id dot azz user id and count, right? And we are resetting the index. So if we check the train data grouped after renaming it, so here you can see that the place id and the score we have, right? For this place we have 2 score, for this place we have 2 score, for this place we have 7 score. Now sort the product on recommendation score. So train data sort. So similarly we will sort the values on the basis of score first, then place id, and ascending from 0 to 1. So here you can see that score is sorted 888, then 77, then we have placed id 1313, and so on so forth, and finally the rank of their corresponding value. Now use popularity based recommender system or model to make predictions. So of course as we are making function, this is what we have been doing since last few videos. So we are defining recommend, we are passing the user id. So user recommendation equals to popularity recommendation. Now adding user id column for which the recommendation are being generated. So in our case it is user id, and bring user id column to the front. So column equals to user recommendation dot column dot to list, right? Column equals to columns minus 1 to all, and plus column. Then we have we are having the columns by slicing them, and user recommendation of those columns, and it will return the values, right? Now we make a list of the user choice. So let's say find a recommendation for 15, 121 and 53. So for I in find recommendation, right, we are printing here is the recommendation for the user ID, then we are passing the values of I. So first time it will give for 15, then 121, then 53. So here is the recommendation for user ID 15. So user ID is this, place ID, score and ranking, and you can see that for 15 we got these recommendations, right? So here the place ID is this, then this one, this one, this one, and their score is here and their ranking is here. Similarly for user ID 121, so for user ID 121 we got these recommendations. Similarly for 53 we got these recommendations. Since this is a popularity based recommendation model, yes, recommendations remain the same for all users. Yeah, we predict the product based on the popularity, so it is personalized to a particular user, right? So for that what we are doing is we build a collaborating filtering. Okay, so as I said that collaborating filtering is nothing but like I have given a simpler example, like if a person X likes items ABC, right, and Y likes items BCD, then they have similar interest, and X will like item D because X is already having AB, right, and ABC, right, and BC is already held by Y. So there is uh, so X should like item D, similarly Y should like item A because they have the similarity, they have the similar interest, right? Now for building a collaborating filtering, so first what we will do, of course we will use the singular value decomposition. So that is a model based collaborating filter we are using, and in which we will be using singular value decomposition, or this is the popular name in the recommendation known as SVD. So SVD is nothing but it is a matrix factorization technique used in recommender system to reduce the dimension of a matrix by dividing it into some similar or the smaller matrices. Now DF of collaborating filtering, so DF PD concatenating train test test set and again reset the index. So we got this DF CF head. Now based user based collaborating filtering, so matrix with row per user and column per user. So here again we are applying pivot function. So for index user ID, column place ID, values rating, and fill NA with the mean value of the final rating matrix. So this way we will get the shape that is 20 row and 71 column. So this is the data frame of the pivot DF. Now pivot DF user index equals to np dot a range 0 to pivot DF shape of 0 1, and actual rating given by user. So here if we get the pivot DF dot head, because here we set the index on the basis of user index, right? So this will return the rating given by the user. So for example for this you can see that the rating, right, and so on so forth. Now next step is to calculate the similarity between the user. So user similarity on replacing none by item movie average. So sklearn matrix pairwise cosine similarity of the pivot DF. Now filling the diagonal, because of course we'll get the diagonal as null, right? Similarly similarity with restaurant, so PD data frame cosine index equals to pivot DF dot index, similarity with movie columns equals to pivot DF dot index, similarity with movie dot samples. So here this way we will get the similarity with movie sample. So we can see that these users are not very similar, right? And you will get to know this on the basis of these values. Now the SVD method we will apply. So SVD is the best to apply on large sparse matrix, right? Basically in a recommender system, SVD divides the rating matrix into two matrix, right? So this is let's see how it works. So from scipy.sparse we are importing the SVDs, right? Then singular value decomposition, so use sigma vt SVDs pivot DF k equals to 10. So construct a diagonal array in SVD, so sigma equals to np dot diagonal of sigma. Here one thing is to note that for a sparse matrix you can use the sparse lin algorithm.svds function to perform the decomposition. Svds is useful in many tasks such as data compression, noise reduction, similar to principal component analysis, and latent cement indexing, used in document retrieval and word similarity in text mining. So all user prediction rating equals to np dot u sigma vt, so predict rating. So this way we will get the predict df all user predicted ratings column. We have the pivoted column. Now predicts df dot head, so this way you will get the values for these. And recommend the item with the highest predicted rating. So this is what the main function. So recommend item, user id, pivot df, prediction df, and a number of recommendations, right? So user id equals to user id -1, because we want to start from 0, and get and sort the user rating. So this is what we will be sorting on by accessing the user index using iloc. So sorted user rating we will have, then sorted user prediction. So first we are having them into temp variable, then index.name, recommended items, and column user rating and user prediction, and finally we will print the values. So let's see how the function will work. So enter user id and number of recommendation for the user. So user id is 10 and number of recommendation we want again 10. So recommended item, so we are calling this function, right, passing the value, the user id, the pivot df that we have earlier, and the number of recommendation 10. So below are the recommended item for the user. So for user id 10, these are the recommended item, user rating of these item, and user predictions, like what is the prediction of these item. So evaluate both the models. Once the model is trained on the training data, it can be used to compute the error. So RMSE, so root mean squared error, so on the prediction made on the test data. So evaluation of model based collaborating filtering. So now we'll do the evaluation. Actual rating given by the user. So first thing first, we are getting the head, that is top 5 values, and then average actual rating for each item. So final rating matrix mean dot head, so this is the mean of each values. So predicted ratings then we have, and then average predicted rating for each items, right? Now RMSE df, so this is what now we are concatenating the final rating matrix dot mean with the predicted prediction df mean, right? And it will print the RMSE df shape. So here you can see that the RMSE df shape we have is 71 rows and 2 columns. Right, and then we are arranging this item index. So here you can see the RMSE df data frame. Now RMSE, we are rounding the values by applying the RMSE formula in it. So RMSE SVD model, so it will give us 0.00034. Now right, now enter a user id and number recommendation for any different user. So let's say user id is 5, 10 number of recommendations. So similarly you will get these predictions. So this way you can apply collaborating filtering even if there is any custom problem you have or any specific problem you have, you can definitely apply it on that, because the calling function or the calling thing will be same. The only thing is your data, right? How your data is organized and how you are applying your data here. So if we have summarized this, so model based collaborating filtering is the personalized recommendation system. So the recommendations are based on the best behavior of the user, and it is not dependent on any additional information. Similarly, the popularity based recommender system is non-personalized, and the recommendations are based on frequency counts, which may be not suitable to the user. So you can see the difference above for the user id 15 and 21. The popularity based model has recommended the same set of 5 product to both, but collaborating filter based model has recommended entire different list based on the user past purchase history. So yes friend, this was all about this video. Hope you liked it. If yes, please do like, share and subscribe. That will motivate us and give and encourage us to come with more videos, come with more content. Our team is continuously working on it to preparing such case studies, so that will help you and that will motivate us to keep working on it. So let's meet in the next video. Till then, all the best, have a good time. Thanks for being with us.